Okay, so in this problem here, I want to show how you can do this problem using the shell method for calculating volumes. So let's go ahead and graph this region. So we're looking at the graph of x equal the square root of y. Well, of course, that's the same as what y equal x squared. So y equal x squared, x equals 0 is the y-axis, and we have y equal 1. So this is our region here. And what do we want to do is we want to revolve this around the x-axis. So when you go to revolve it, it looks something like that, right? Okay, there's a disk on the inside. So if we were to do this by disks, how would we do this? We would have to calculate, we need the outer radius, which is this distance here. So the outer radius is what, 1, and then your inner radius is x squared, right? Here's your inner radius right there, x squared. So doing this by disk, we calculate the volume, be pi times the outer radius squared minus the inner radius squared dx, and we're integrating from what? 0 to 1. This is 1 and this is 1. Okay, so that's how we would calculate it doing disks. Now to calculate doing shells, remember what shells allows us to do is it allows us to compute the volume of a cylindrical shell inside of here. So I'm going to use the same kind of round thing, and it goes down like this. Okay, so you have some cylinder in here, and remember the volume of a cylinder volume of a cylinder is what? 2 pi radius height. Okay, 2 pi times the radius times the height. So in this case, what is the height of the cylinder? Well, it's pretty easy to see. It's just this distance right here, which is the square root of y. And what is the radius? Well, here's your radius. It's right here, just y. Okay, so the volume is pi, and you're going to have y, or excuse me, 2 pi, y times square root of y dy, and you're integrating from what? 0 to 1. Okay, so which integral is easier to do? This integral here is easier, a bit easier to do than this one. So you can go ahead and calculate them yourselves and make sure that you get the same answer.